We're ready now for problem 5. I think I may have misspoken at the end of the last video because I took a quick look at number 5. I think this is another law of sines problem. So once again, solve for the angle ABC, and they give me gamma is 71.5 degrees. A is 17.36 and C is 20.25. So this is angle side side, but then it ends up being a matching because the gamma and the C. So this is going to be another law of sines, and this is going to be one where you could have 0 triangles, 1 triangle, or 2 triangle. So basically we need to find the angle alpha, we need to find angle beta, and then side B. So the right place to start is sine gamma over C equals sine alpha over A. So we can figure out angle alpha. So the sine of 71.5 degrees over C 20.25 equals the sine of alpha over 17.36. So the sine of alpha is going to be 17.36 divided by 20.25 times sine of 71.5 degrees. So I'll do this calculation, and then I'm going to go ahead and take the inverse sine just to save a little bit of time since we've done these problems already 3 or 4 times. 71.5 sine times 17.36 divided by 20.25 is 0.8129. I'm going to go ahead and take the inverse sine, 54.39 degrees. And I can look at the answers and see that that is in fact correct. Now I put the star here because I'm going to have to go back when I check for my second triangle. This is my starting point. So now let's go ahead and get angle beta. It's going to be 180 minus alpha minus gamma. So when you do that, you end up with beta is 54.11 degree. Now, last thing is to find B. So use the law of sines. I'll go ahead and just do gamma again. So the sine of beta, sine of 54.11 degree. I don't know B. Sine of gamma is sine of 71.5 degree over C 20.25. Cross multiply and solve for B. I got to be careful about this. It's going to be 20.25 times the sine of 54.11 degree over the sine of 71.5 degree. So 54.11 sine divided by 71.5 sine times 20.25, 17.30, which is correct. So this is the first triangle. Is there a second triangle? You start here. The second triangle, the alpha is going to be 180 minus the alpha from the first triangle. (162.70 degrees). Now, based upon this, the new beta would be 180 degrees minus the new alpha minus the original gamma. So let's see what this negative 54.2 degrees. All right, so there's a case where looks like there's only one triangle, because when we check the second triangle, we come up with a negative angle, which is not possible. All right, number 6, hopefully. Maybe we get to the law of cosines. Let's see. So once again, solve triangle ABC. Beta is 143 degrees. Side A is 150. Side C is 31. Sorry about that. All right, what do we have here? We have angle, side, side. And it turns out this is non-matching. Now, if you got confused and for some reason you tried to use law of sines here, you'd find out you can't do it. It wouldn't work. So the only option is use law of cosines. And there's, of course, the 3 equations. But the one that involves angle beta is the b squared equals a squared plus c squared minus 2ac times the cosine of beta. So we know everything. Well, let me mark a part we need to find. We need to find side B, need to find angle alpha, need to find angle gamma. So 2 angles and 1 side. So I know everything in here, this equation except B. So I can start plugging in. A is 150 squared plus C is 31 squared minus 2 times A times C times the cosine of 143 degrees. Now, usually when students mess up on this kind of problem, it's order of operations. They don't do the math correctly. We have to first go ahead and figure this out right here. Multiply 2 times 150 times 31 times this cosine. You do that all first. Times 31 times 150 times 2. And that is minus 7427.310. So when you subtract the negative, it ends up being positive. So now 31 squared, 961, and 150 squared, 22500. So basically we're adding all 3 of these together. So when I do that, plus 22500 it's a really big number, 3888.310. Get the square root of both sides to find b. See what they say to round to. And nearest whole number. So this is 175.75, so it's 176. That actually is the correct answer. So now I need to find angle alpha and angle gamma. And now I'm going to go ahead and some of you might choose to do law of sines, but if you do law of sines, you don't have a choice of which angle to find next. You have to find the angle with the smallest side. So if you're looking for angle alpha and gamma, if you want to do law of sines, you'd have to do the gamma next, or you're going to get the wrong answers. I'm going to go ahead and do law of cosines, because law of cosines, it doesn't matter. So if you don't want to have to remember this rule about which one to do next, or that confuses you, don't worry about it. Just use law of cosines again. How about for alpha, a squared equals b squared plus c squared minus 2bc times cosine of alpha. We know everything here about alpha, so we can plug in all these numbers and eventually calculate alpha. So a squared, 150 squared. B is, we just found B, 176 squared. C is 31 squared minus 2 times B, which is 106 times C, times cosine of alpha. Now here's the trick. Once again, students make a mistake because I don't do the math correctly. I have to go ahead and square this and subtract both of these. Move both of these over here. So you're going to see 150 squared. It's 22500. I'm going to square 176 and then subtract it. I'm going to move it over here. So I have to subtract 30,976 and then subtract 31 squared, 961, and that equals, let me go and multiply these three numbers here. 2 times 176 times 31. First of all, it's negative. So 2 times 176 times 31, 10,912 times cosine of alpha. Let's combine these. So 22,500 minus 30,976 minus 961, negative 9,437 equals negative 10,912 times cosine of alpha. If I divide both sides by negative 10,912, because I want to solve for cosine of alpha, I'm going to get 0.8648, and then I have to take the inverse cosine of that, and you get 30.13, but since they want whole numbers, 30 degrees, let me make sure about that. So that's interesting. They got 31 degrees. Once again, these precision things can drive us crazy. Let me take a quick look and see if I can figure out why they got 31 degrees. Should be pretty straightforward. All right, so here's, and this is just really bad. I kept these digits here, but you know what I do? If I decided for some reason just to ignore those and just leave it as inverse cosine of 0.86, then I get 30.68 degrees, which rounds to 31 degrees. So that really is, in my opinion, not great. But the good thing is, on the exam, I'll be checking your scratch paper. And if you happen to miss a problem because of this kind of thing, I'll of course give you full credit. So don't fret too much. Just do the best you can. If the numbers aren't quite perfect, you'll still get credit. So now the last angle is gamma, and I can just quickly subtract alpha, subtract beta. Now this I could probably do in my head. This looks like 174. Of course, if my math skills lately, I'm going to check that. Looks like 6 degrees, which is actually correct. All right, so that's law of cosines problem. Question number 7. Another, find the triangle ABC, round to 3 decimal places. Great. And here they give, all right, this is problem 7. Side A is 11, side B is 16, side C is 28. So here, side, side, side has to be law of cosines. That's really your choice. If you want to find angle alpha or angle beta or angle gamma, it doesn't matter. I guess we'll just start with alpha. So the equation with angle alpha is a squared equals b squared plus c squared minus 2bc times cosine of alpha. I know everything but cosine, I know everything but alpha, so let's plug it in. So a is 11 squared, b 16 squared, c is 28 squared, minus 2 times 16 times 28 cosine of alpha. Just like the last problem, I have to take this, subtract, so 16 squared, I'm going to subtract it to move it over here. 16 squared is minus 256. Then also subtract 28 squared, move it, square 28, and move it to the other side. That's minus 784. If I multiply these out, 2 times 16 times 28, negative 896 times cosine of alpha. So I combine these and then divide by negative 896. So 121 minus 256 minus 784 equals, divided by 896 negative 1.025 equals cosine of alpha. Alpha is the inverse cosine of 1.025. Take the inverse cosine of that. .025. You know what I get? Error. That can happen sometimes when you have 3 sides. Turns out it's not really a triangle. Now, this is actually the correct answer, but on a test, I would go back and check my math again. Make sure to make sure any mistakes. I didn't miscopy something, but this can happen sometimes. So number 7 is no solution. All right, number 8. I think this is the last triangle problem. To the nearest degree, that's good. So here they give us side A is 10, side B is 15, and side C is 12. So obviously, 3 sides, law of cosines, find the 3 angles. We'll do alpha first, so it's a squared equals b squared plus c squared minus 2bc times cosine of alpha. 10 squared equals 15 squared plus 12 squared minus 2 times 15 times 12 times cosine of alpha. We've done this a lot now. This is be 100. I'm going to subtract 15 squared, subtract 225, and then subtract 12 squared, but I thought it was 144. And that equals 2 times 15, which is 30. 30 times 12, pretty sure is negative 360. I better confirm that. Yep. So this divided by, so 100 minus 225 minus 144, negative 269 divided by negative 360 is cosine of alpha. You do the inverse cosine of that. .6, which is like 42 degrees, which thankfully is correct. Now you need to find angle beta or angle gamma, and you have to use law of cosines. So let's just do beta. So the equation with angle beta is b squared equals a squared plus c squared minus 2ac times cosine of beta. So 15 squared equals 10 squared plus 12 squared minus 2 times 10 times 12. I'm going to try and do all this on my calculator pretty quickly since we've done this many times now. 15 squared minus 100 minus 144, and that's going to be divided by a negative 240, and then that's going to be inverse cosine. So if you do all the math correctly, you should get 85.45, which ends up being 85 degrees. And then finally for gamma, we could just take 180 minus alpha minus beta, and you get 180 minus 42 minus 85. So there we go. All right, so that's law of sines and cosines. Now there are a few more problems with law of sines and cosines. Let's go ahead and do 9 and 10. And then we're done and we'll be ready for vectors. So let's see what 9 and 10 are. They look like they're sort of like story problems a little bit. Let me read number 9. 2 automobiles need to stay at the same time and travel along straight highways that differ in a direction by 80 degrees. So here's the 2 cars start here. We're going to say one car goes this way. One car, they said there's like a 80-degree difference. It's car 2. Their speeds are car 1 is 35 miles per hour. Car 2 is 50 miles per hour. How far apart are they after 40 minutes? Well, 40 minutes, we need to convert to hours since these are miles per hour. 40 minutes is like 2/3 of an hour, right? If you forget how to convert these unit fraction, 60 minutes, 1 hour, 40 over 60 is 4/6, which is 2/3. So really, 2/3 times 50 is how far this car has gone. So what's 50 times 2/3? Let me just leave it as a fraction for now. This car has gone 100 divided by 3 miles. This car, 35 times 2/3 is 70 over 3. So really, what do we have? Side, angle, side. If I want to call this alpha, this would be side A. If I want to call this beta, I'll call this B. If I'm going to call this gamma, this is C. What do I have? I have alpha's 80 degrees, B is 100 over 3, C is 70 over 3. I have angle side, non-matching. Have to use law of cosines to find A. So A squared is B squared plus C squared minus 2BC times cosine of alpha. I know everything here but A. So 100 over 3 squared plus 70 over 3 squared. These fractions make it a very sort of ugly problem. Probably been better if I written these as a decimal. Times cosine of should probably convert these to a decimal. 100 divided by 3 is, this is actually 33.33 squared. 70 divided by 3, 23.33 squared. So this is 2 times 33.33 times 23.33 times cosine of 80 degrees. On my calculator, I can do this whole thing. Start with cosine of 80 degrees times 23.33 times 33.33 times 2. It's like negative 270.05. So 33.33 squared plus 23.33 squared equals minus 270.05. A squared is 1385.13. So if I didn't mess up, $37.2 miles, and they said round to the nearest mile. 37, that's actually correct. Wow. So that's a law of cosine sort of application problem. So now problem 10, another sort of story problem. Triangular plot of land has sides of length 430, 340, and 170. So 430, Now this triangle is obviously not drawn to scale. That's okay. Approximate the smallest angle between the sides. The smallest angle, hopefully common sense says the smallest angle has to be the angle across from the shortest side, right? If I try to draw this to scale, I should probably try it. So 430 is going to be the longest one. 170 is the shortest. And then 340 is the next longest. So hopefully you can see that the angle opposite the shortest side is obviously going to be the smallest angle. Let's just call this angle alpha. So we'll call this A. 430 we'll call B. So you can see this is going to be a law of cosines problem where I'm trying to find alpha. So I have A squared, which is 170 squared, equals B squared plus C squared minus 2 times B times C times cosine of alpha. So let's go ahead. I'm going to take this number and subtract this from it and subtract that from it. Let me do that on my calculator. I can do it all at the same time. 170 squared minus 430 squared minus 340 squared negative 271600. I multiply these together. 2 times 430 times 340 negative 292400 times cosine of alpha. Cosine of alpha, divide both sides by the negative 292 times, hope that was a 271. It's hard to read my writing. So negative 271,600 divided by 292, 400.929. Take the inverse cosine of that. 21.7. I don't know what they want me to round it to. The nearest degree. That's correct. All right, so problem 11, we start with vectors. So let's stop now. We start working on vectors and then eventually the other stuff.